Hey guys, it's Marty and welcome to Two Line Slot Cars. For the last year or so, we've been using our track analog a lot. And we've tried lots of different ways to time cars using different pieces of software. We were running Smart Race in analog mode for a while using an iPhone, and that did a really good job. And then we started wanting to do round robin racing, so we moved to Race Coordinator and figured out how to use a webcam for it. And a friend of the channel, Thomas Seidner, he reached out to me and said, hey, Marty, I built this hardware that basically is a photo eye in each of your slots, and it uses an Arduino device to communicate with Race Coordinator. And it's super easy. And sent me a link to his video. I watched the video and I'm like, I can do this. So this video, guys, is just going to be a breakdown of how you build your own track timing hardware. It really wasn't that difficult, and it really works well. So let's just get into it. Okay, I am attempting to build hardware for lap counting, and on Amazon, I picked up this IR sensor. And I'll put a link in the description. And it's basically a slot IR sensor. So whatever goes between that slot, it will measure. And I will use Arduino to basically process that for the computer. So my plan is to take my Dremel. It's got an 1.5 inch cutting wheel. And in these sections here, I'm going to cut down through in both lanes. I'm going to cut down through and make room to be able to mount this straight across the slot. And so to do that, you have to cut down through here all the way just below the surface of this slot, right? We don't want to eliminate the slot or eliminate the rail, so we want to cut underneath all the way down. So here we'll make a cut, and then we will make a cut here, and then we'll clean out that piece of plastic, and we'll clean out the slot so that there's an open gap between the rails. And then what we'll do is cut that inside of each rail and bend that down so we don't lose any contact, but we do eliminate between the slot, the plastic, and the rail, so that this sensor will mount this way down in there to be able to catch the guide as the car comes through. Now, we will have to deal with a little bit of height, because once you put that in, it will stick up. And I think what I'm going to do is just mount maybe just some small pieces of plywood, scraps like that laying around, just so that the weight of the track does not sit on those couplers, those sensors. It will raise the track just slightly, but it'll protect the wires and protect that sensor from being bent or broken. So now let's I have a 4-lane track, so I've got to do this 4 times. So let's start cutting. And so basically I cut a slot out, and I'm going to build this up a little bit, but you can see here the sensor is in there. And even with a short guide, it will still, what I'll do is I'll paint a start finish line, and we'll give it a test. So now I'm going to wire this up and see about getting it to communicate with this, and see if I can figure out how to program, because I am not a programmer. So this ought to be fun. Okay, and we're going to run a little test. I've put power and ground to the chip or the sensor, which is built into the track. And what I want to do is if the car breaks the plane, so I'm going to run the guide through, it should kill the light. And you can see, there we go. Breaks, kills the light. Now we know that that works. We are passing data to the Arduino connected to this. So now I just need to program the Arduino to tell race coordinator that was a lap. Okay, now let's fast forward. Basically what I did was I cleared that slot out. I glued the sensors in, and then I wired them up. Now you need to understand there's 3 connections on these sensors. One is the output, that's the data. One is the VCC, which is the power, and then a ground. And each of those will go to the Arduino, and I'm using an ELEGOO UNO R3. So we'll wire that straight. So I marked, just so I know, this is the blue lane and the white lane, and then I've done the red lane and the yellow lane. Now, my friend Thomas Seidner, he's the one that came up with this concept using these sensors. He took the sensor apart so that you get that to lay flat. But I think what I'm going to do is I have some scrap pieces of plywood that are about the same height as the sensor. And I'm just going to glue them here and here, here and here, just to raise that track up slightly, just so that there's no weight resting on the sensors. But got them pre-wired, ready to go to the Arduino, and that's where I get lost because I do not know how to program this thing, so this could get interesting. But that's the basics of installing it in a piece of track. Very easy. You could take those apart and get them lower, but honestly, I just put a little bit of, on the end here, I just put a touch of super glue, gel super glue, and glued it in place. I just set it right down on the bottom of the rail, as deep as I can get it, so that even if the guide is short, it'll still set off the sensor. And then once that glue set up, I then came around with like shoe goo type of glue, or you could use a hot glue gun, and I really built the glue up around that. So, and then once I put the wiring on, I put some tape down just to relieve any kind of pressure from the wire, so that there's no pull or tug at those. So there you have it. Now let's get it in the track, get it hooked up, and see if we can make this work with Race Coordinator. Okay guys, I've been working on my lap counting system, and I've put the piece in, painted a start finish line. If you can see closely, I have the sensors in each lane. I have at the end of the straightaway, so that I didn't have to worry about these slots going across and mistiming. So I need to snap the track back together, but I'm just testing this, and that's wired up. You can see some of the wires. I still have some cleaning up to do, but each sensor is wired over, and it comes into an Uno. This is an ELEGOO, basically an Arduino Uno card. So USB into the computer. The computer has HDMI over to the board, and we've got basically lanes 1, 2, 3, and 4 coming into the board. I've got 3 volts of power that's powering those, the photo eyes. And then I've got 5 volts that's coming out and powering I bought the same company. I've tried a couple different relays that didn't work, got the wrong ones. This has to be a 5-volt relay module. This brand, I got a 4-channel just in case, mainly the same price. But this is specifically made for Raspberry Pi or an Arduino. And you can tell that the load voltage is, operating voltage is 5 volts, so it can get powered from the Uno card. But it will do up to 30 volts DC, which I've got a maximum of 20 volts coming out of my 20 volt 10 amp coming out of my power supply. And so power supply comes in here to the relay and out off of channel 1. And then I've got a ground that's going over to the Arduino board. I've got power, the 5 volts, which powers this. And then this, let's see what color, brown cable is actually my signal cable for channel 1. And I've got it plugged in to the master relay and race coordinator. So if we look at race coordinator, the app, let me kill this. You go into, sorry for the reflection, you go into track setup and then expert track setup. You'll set this up for the Arduino. All right, so we configure it. We want to trigger laps on low. So what happens is the photo eyes are lit, and when it drops, that's what signals for the laps. My Arduino is plugged into COM4, so you'd select the COM and leave everything else the same. Then you'd go to the analog setup, and you can see how I've got mine set up is on the analog side of the Arduino. Pin A0 is laps lane 1, laps lane 2, laps lane 3, laps lane 4, and then I used pin on the analog side, the master relay. Okay, it's red because how that works is when this is lit, it's killing the circuit. When it's off, the circuit is live to the track. So I just hit accept, and you can test that by clicking this button. You can hear the relay kick on and off. Okay, so I'm doing that here. So then we accept that, we update, and then we go back out. All right, so then if we set up a race, we'll come here, I'll choose, I'm the only driver. This is race coordinator. I'm the only driver. I will choose a round robin race. I will hit start. Actually, I'll just pick practice because it will work in practice as well. So right now the track is dead. You can see nothing, track is dead. And I also took one of these boxes that has the switch just temporarily. That's my call button, and basically it's wired to a ground on the Arduino and then pin number 12 on the digital side. That is the call button. Okay, so what we'll do is we'll start practice. You'll hear it. Okay, so it says go. The countdown time is timing. We come over here. We have power to the track. We cross the line. You can hear that it counted the lap. Cross the line again. Driver 2 best lap. My white lane is my number 2 lane. driver 2 best lap. Okay, so you can see that the lap counting is working, 3 laps, and the timing is working, all off those photocells. But then here we go. See if I can do this. And I want to test the call button. So I'm gonna hit the track call.
Yellow flag.
Yellow flag. Race is paused. You see the timer is not moving. And track power is dead. And then, here, I'll pump up the volume just a touch so you can hear it.
Go.
Go. Track power is back, counting laps. And we have now built lap counting hardware to run on Race Coordinator. We have
Yellow flag.
Yellow flag, you can see it lit the light. That means there's no power, that circuit is broke.
Go.
Now we're back. And this is wired up. The second box,
Yellow flag.
it does the same thing.
Go.
So I actually have 2 call buttons ready to go. And folks, that is what you need to lap count and control track power. Now, I need to tidy this up a little bit. I've got call buttons coming. So these are just temporary until I get my call button. But I'm planning on having 2 call buttons on the track. One for whoever's managing the race, and then when we don't have marshals and somebody directing the race, we'll have another call button near the driver stations so that we can hit and kill the power. And so without marshals, that's the only way you can really do racing without marshals, is to be able to do track calls and kill the power. So guys, that's it. That's what it takes to build your own track hardware, your own timing hardware. Fairly inexpensive. Get everything from Amazon, pretty easy to program. If I can do it, I know that you can do it. The only thing that we run into is the photo eyes have problems with things that are light in color. So if you're using an NSR guide that's white, the beam reflects back in and it doesn't cut the beam. And so we've done a couple of things. You can take Sharpie and color in your guide to make it dark so that it absorbs the light, not reflects the light. And it works fine. So NSR guides, Thunderslot guides sometimes work, sometimes don't. But if you just take a Sharpie and color it in, you're good for about 100 laps before the Sharpie wears off. The other thing you can do is you could dye with like RIT black dye your guides that are white. And that would work too. Then it would be permanent, right? So we're going to explore some ways to maybe improve that and maybe correct that. Rob, one of his channels, he mentioned that he was able to design his own photo eyes that didn't have that problem. So hopefully I can reach out to him, get some information, and build my own, and I'll update this video. So if you have any questions, my email is in the description of my channel. You can send me an email, ask me any questions in the comments. I'm happy to help you. If you want to design and build your own, I'll put a link of all the parts that you need to order from Amazon. And really, guys, it's pretty easy. A Dremel, some super glue and some shoe goo, a hot glue gun, and some wire, and a little bit of know-how and understanding of the racing app that you're using. And you can create your own very clean, neat, built into the track, lap timing counter, and you can control the power. You just have to buy the right relay. It's working great. Super happy with it. Excited to share this with you. If you like this kind of content, hit the subscribe button. Give me a thumbs up. Hit the bell so you get notified anytime I put out new content. Guys, I really appreciate how you support my channel. I hope that you continue to like things like this. Is it all about slot cars? No. But it's about improving your track and improving the experience on the track and being more precise about your timing and doing some DIY things. You know, some of us, we just like to dig in and use our hands and build something. And in the end, when it works, it's pretty satisfying. So if you like this, make sure that you subscribe to the channel. Guys, thanks, and get out there and go have some fun racing.